and let me know if it works, and then we'll get started. Okay, so it seems like it's working, and I'll just get started once I have some Q and A's to answer. And yeah, we'll be sending recordings and slideshows shortly for everything that we've done so far. All right, so SQL overview. This sort of ties into a lot of stuff we're doing in the last presentation as well with Amazon Web Services storages and databases. So this is again just some stuff about me. And just like some of the stuff that I like to do for fun. And it's important to like do stuff for fun because like trying to push for like a career all the time is, especially since you guys in high school and middle school, you should take the time to just enjoy yourselves and have something fun to do. Not only just to like better yourself, but also just to take a break every once in a while. All right, so SQL. What is SQL? How is it used? And again, this is sort of an educational slideshow, but like I said, like I research a lot of this stuff and found a lot of this stuff from like internet websites. So I'm not going to say that it's like completely 100% accurate and it can't be used for like actual like professional teaching or advice. But I'm just here to help you guys get a foundation for learning and researching and try to find out some of the stuff on your own. Okay, so one of the foundations of SQL, of SQL SQL, is the difference between DBMS and RDBMS. So DBMS is a database management system, and RDBS is a relational database management system. So basically, like I said in the last slideshow, and a difference between an RDBMS and a DBMS is basically that one deals with relational databases and one deals with just normal databases. So in normal databases, like I said before, there's like a fixed schema. There's like tables, columns, rows. But in RDBMS and relational databases, it's more like a key value pair, and it's more of a key value pair type system. So the foundations of almost all databases is in the idea of a database having tables, and each table is having columns, and the columns have rows that go along with them. So let's say you have a table about employees, and in that table about employees, there is in that table about employees, you have columns like the employee's name, their date of birth, the day they were hired, their salary, their commission, their department, their social security number, anything like that. So in that table about the employees, you have different columns relating to the stuff that are about those employees, and each row is an entry. So let's say me, date of birth, hire date, salary, commission, department, social security number, all like that. And that's the foundation of everything that we're going to do here is databases, tables, columns, and rows. That's what SQL runs on. And so we're just going to like basically talk about how databases work. Like the way you play around, the way you use databases is fundamentally you create tables, you add data into tables, then you either retrieve the data or update the data by adding or removing. Adding, removing, or editing. So what is SQL? Like where does SQL go into all of this? SQL stands for Standard Structured Query Language, also pronounced as SQL or SQL. You'll hear people like pronounce it either way. And it's basically a computer language for storing, manipulating, and retrieving data in a relational database, in a SQL database. And its syntax is kind of like coding. It is a computer language, but the syntax is actually more like plain English. It's actually more like the way you say it or the way that it's written out is basically exactly what it does. There's not like a lot of convolution in the way it's written. And it's an American National Standards Institute standard, which is basically just a standard for computer languages. But it only communicates with relational databases, no other type of databases. So there's a lot of different like types of SQL commands, and this might seem like kind of intimidating on first look, but the basic ones are data definition language, data manipulation language, data control language, and transaction control language. Data definition language is defining new data. You can create a new table, you can alter existing tables, or you can delete entire tables. So this is dealing at a high level with creating, changing, or updating tables, not individual data, just the tables that the data is stored in. Data manipulation language is for actually changing the data in the databases, not the table. So you can insert new records, you can update existing records, you can delete existing records, and you can select existing records, which is retrieving them. So you can read, write, delete, and you can read, write, and delete. And there's data control language, which is how you control who has access to that data. You can grant people privileges, or you can take away the privileges to view certain confidential information or information available to the public. Then there's transaction control language, which is basically committing changes or rolling back changes. So say you make a change to database and you commit that, and then you make another change later, but you realize you messed something up. You can roll back to that previous commit and start over from there. So let's like your mistake didn't happen. Okay, so the first thing in data control language is the create method or the create command. So data in RDBMS is stored in database objects called tables. And tables are kind of like the same way they're in spreadsheets, the same way you use in like graphing, the same way you use in I don't know, like any statistics class. Like data is stored in tables, and tables consist of columns and rows. And there are a lot of database objects that can be created using the create statement. You can create tables, you can create indexes, you can create views, and create stuff, and so on. Basically, the data definition language allows you to create new databases. It doesn't let you change the data within those databases, but lets you create new ones. So some of the different types of database objects are tables, which are like the basics. They have rows and columns. There's views, which is subsections of those tables. So let's say you want to look at just employee ID, employee names. You can make a view that has just employee IDs, employee names from this existing table. There's indexes, which allows you to improve the performance of retrieving data. You can also create sequences, which is like kind of numeric values, but that's a little bit more complicated and not used as frequently. So the syntax of the way you create a table is the command you type in is create table. That's how you create a table. You type that create tables command. You have the table name, which is the name of the table. Then you put parentheses, and you have the column name, which is the name of the column. I'm going to say employee ID with a data type of, I don't know, a number. And then the default expressions is if there's a default value that you need. This doesn't have to be there. That's an optional parameter. So let's say you want the default date for hire date is just the date of the system date of when you put it in that when you added it into the column. So you can just have that be the system date and have that hire date automatically put into your table. But as you can see, it's kind of like plain English. It's kind of like the way you say is create table name with all the columns is exactly how the command works. It's not that complicated once you know the syntax of it. And the different data types that are available are varchars, which are variable length character data. So they're variable length strings, like kind of strings. So you can have like the employee name, for example, would have to be a variable character because it could be like someone's name could be 3 characters long, it could be like 20 characters long, and you don't really know that off the top of your head, so you have to have that variable. You can have fixed length character data. So let's say there's an employee ID number at your company, and employee ID numbers are always a sequence of 8 letters or numbers. So you can have the employee ID always be an 8 character size, a fixed 8 character column. You can have numbers, you can have date and time values. Those are different data types that are available. And like this is an example command, like I said before, create table employees. Then the different columns would be employee IDs with a number, employee names have a variable character, department IDs is a number, and hire date is a date, but the default is a system date. So whenever you add them, the date that it is currently, when you add that new employee in, that's their hire date. And then you can also create constraints. Like there's even more you can do with the command called constraints, which lets you change the way you create a table to have like even more customizability. So let's say not null. So that means the specified column cannot contain a null value, which means you have to put something in. Like you can't just have that column blank. So the employee ID, you can say employee ID is a number that's not null. So no matter what, every employee must have an ID. Otherwise, you can't add them into the database. Then there's like unique, which means represent a subset of data from one or more tables. So you can have their employee ID be a number that's unique from another database where you store their employee ID, so you can take it from another database. Then there's different things like primary key, which is improving the performance of retrieving data. So you can have their employee ID number be really, really fast in retrieving. So no matter what, you can call any employee by their number and get the information about them really quickly. Or just numeric values, which is, let's say, their marital status or their salary. You can have it basically be like a 1 character based on whatever they input. So DDL alter table. Alter table is another one of the big commands in data definition language for altering existing databases. Like I said before, you don't make any changes to the data, you alter the databases, the large tables themselves. Alter table is to use to change a column's data type, change its size, change the default value. So that's one of the things you can do. So you can alter table employee one. You can modify, which means you change something about a column. Let's say you want the employee named. You realize some of your employees have names that are over 50 characters long instead of 30. So instead of doing 30, you can modify employee name to be a variable character of up to 50 long. You can add more columns to an existing table. So you can alter table employee one and add a new social security number column. You can have that as a character or a varchar, even though social security numbers are always 8 digits long. No, 9 digits long. And you can also drop existing columns. So you can alter table employee one and drop the social security number column you just added because you realize, oh wait, we don't really need to store those social security numbers. Okay, and the next data definition language is drop. So there was a drop here, but that drop was part of alter table for dropping columns Oh, is the audio working now? Um, Wait, let me know. Yeah, let me know if the audio is back now. And if you guys need me to go back, if there's any, do you guys need to go back a few slides? Okay, I'm gonna go back a few slides. Sorry about that. Seems like I just cut out. Um, I will. Sorry about the spam and everything. I just, it like this the screen takes up a lot of my slides, so I'll move back to alter table and start from here. So the alter table command, like I was saying, basically you can change. So alter table is part of data definition language. So instead of changing the data in a table, you change the tables in a database. It's high level. So you can change the column type to, and using modify, you can change the employee names from being 30 characters, 50 characters. We realize some people's names are really long. You can add more columns to an existing table, like adding a social security number column, or you can drop some existing columns using the drop command. But now we're talking about data definition language, which is, this is still data definition language. So you can remove tables from a database. So you can drop entire tables. You can move tables to, actually, no, when you drop a table, it'll go into what's called a recycling bin in Oracle. And you can show something, you can go into the recycling bin and actually permanently delete them, like you do on your computer. Like when you delete a file, it doesn't actually delete, it goes to the recycling bin to delete it from there. But in SQL, you can do what's called purge and completely remove it instead of it going to the recycling bin. And now we're on DML, which is database machine language, which is instead of changing the tables, you actually change the individual data within them. So insert is the first command. So insert is the way you insert data into every column of the table. So insert into whatever the table is called, values, and all the values that you need. The thing is, you must list the values in the same order as in create table. You can't just switch around the order and hope it figures it out on your own. You have to insert it in the same order, which seems like self-explanatory, but it's something that you can always mess up pretty easily. And you have to also make sure that you insert it into every column. You can't just like skip columns as well, because then that messes up the order too. And if you don't know the data table, instead of just leaving it blank or not putting it in, you have to put null. Otherwise, you can't insert the table without having something, at least something, even if it's null, in every column of the table. And you close characters and dates with single quotes, kind of like in a lot of coding languages. You encode the strings in quotes, and you don't have to put anything around the integers. And the values and quotations are case sensitive. So if I wanted to put my name in a database, like if I put my the first letter capital, or put all caps or all lowercase, those are all different values. They're not the same. And the syntax for inserting data into a selected column, like if you don't want to put a new row for everything, if you just want to insert data into a selected column, you can do insert into table and choose the columns, and then put in the values. So if you just do insert into table, you have to put in for every column. But if you specify column 1, column 2, you just have to put values for column 1 and column 2. And there's even more stuff you can do with insert. So you can insert rows with null column values. So if you do insert into employee name salary, you can insert my name and the salary that I have. Or you can do name, salary, department ID. And if you don't know my department ID, you can just add null and have something exist for all three of those columns. And null is just a blank row. It doesn't mean anything. It has no value. Or you can do special values. So instead of specifying, let's say for the date you're hired, instead of specifying the exact date you're hired, what you can do is every time someone is hired, you can have it pull what's called the sys date or the system date. This is the time, the current time that it is based on your system's location. So let's say right now it's 1:28 in my location. It'll pull that 1:28 at July 11th and put that into the database. And you can also, if you don't want to do that, you can also format the date and have it do like what's called to_date, put in the string of the date and the way you wanted to model. So you can have 07/03/2021, and you can format that in terms of month, day, month, year, month, date, whatever way you format it based on like where you live or what you're trying to do. And then the next command in DML is update. Update, instead of inserting new values, you update the existing values. It's kind of, like I said before, it's kind of like you say it how it works. So the basic syntax is you update table, then you set the column equals value, then you say like where this certain condition if you want. So the optional thing is like where the condition happens. You can update more than one row at a time. You can include, you can change values for specific rows or rows. We specify the where command, which is kind of like an if statement, like if the certain condition is met. So let's say update employee and set salary equals 200,000 where the name is Mehar. So what this command does, I'll break it down. So you update from the employee table. So you're in the employee table right now, and you want to set the salary to equal to 200,000. If you just put salary equals 200,000, then that would set everyone's salary to 200,000. But you don't want that. You just want to update one person's salary to 200,000. So you do update employee, set salary equals 200,000, where the employee name is equal to Mehar. So it would find where in the table employee name is Mehar and just update that person's salary to 200,000, no one else's. Yeah, so like I said before, if you omit the where clause, then everyone's data values are changed. And you can also set the salary to null if you want, just like everything else. The next DML command is delete. So delete is where you can remove existing rows from a table by using the delete statement. So delete from table, you can delete entire rows, and you can also have the where condition this one. So the brackets mean it's optional. So let's say you delete from employee where the employee name is Mehar, then you can delete the row in the employee table where I am. So let's say I get fired, you can delete my row from the table and it'll update it, and so then you don't have to deal with me being in there anymore. But if you omit the where clause, then it deletes everything. So you don't want to mess that up. So if you want to specify a specific row or a specific condition, like let's say delete from employee where salary is over 10,000. It'll delete everyone whose salary is over 10,000, but leave everyone else. Then there's select. So select is where you can select existing rows from a table by using the select statement. So select, this is one of the ones you'll use the most in SQL from my experience. So you can select all distinct. So these things in brackets are like optional parameters you can add, and I'll explain what they do. So basically, you select whatever you want to add from the table, and you can have a where, condition, and order as well. So the condition can be an inequality, a comparison, a logical operator, like logical operators are and if both conditions are true. So say salary is over 10,000 and hire date is later than 2016. Or you can do or where the salary is greater than 10,000 or the salary is less than 2,000. Or you can do not. So let's say not salary greater than 10,000, which means it'll take the opposite of that and select everyone where the salary is less than 10,000. You can order by, which will sort the data that returns based on ascending or descending order. All or star will select all rows, keeping duplicates, if any, also in the output. So select star from employee will like literally select everything from the employee table and return it back to you. But if you do distinct, then that will select only the distinct clauses, not any, and eliminate any duplicates in the output. So the same thing as so you can just select like star from distinct, or you can just select distinct from certain columns from the employee table and only return the specific ones. And there's a lot more you can do with select as well. So you have where conditions, so where clauses. So let's say select star from employee where employee name is equal to Mehar. So that would normally, if you just omit the where employee name equals Mehar, that would select everything from employee. But if it's where employee name is equal to Mehar, then it just returns my column. I mean my row, not column. In and not in clauses can be used in where clause to filter the data, and to retrieve all employees whose name is specified in the in clause. You can do select star from employee where employee name is in Mehar, Dhruv, and Arsh, like here. So what this does is select everything from the employee table where their name is in this list. So if their name is Amol is not in Mehar, Dhruv, or Arsh. So it doesn't select them. But if their name is Dhruv, then it selects their name. So it returns, what this returns is the information about Mehar, Dhruv, and Arsh and no one else. Or you can do not in, which is the opposite. It says select star from employee where employee name is not in Mehar, Dhruv, and Arsh. So this will return everyone except for Mehar, Dhruv, and Arsh. Hold on. Oh, wait, there's one last one. And then you could also have the in condition is also helped to like reduce the need of using multiple or conditions. So like usually, like let's say you want to select employees where the states were in New Jersey, New York, Arkansas, and Kansas. Then instead of doing where state equals New Jersey, or state equals New York, or state equals Kansas, or state equals Arkansas, we can just do where state in NJ, NY, Arkansas, and Kansas. And there's even more you can do with select. So like I said before, select is, since it's one of the main things you need to do, there's a lot of stuff you can do with select. So you can also do and or clause with where clauses. So let's say test multiple conditions, but you have to remember that order of operations matters. The parentheses, the way your parentheses work, does matter. So you can select everything from employee. This is an example command. Select everything from employee where their state is New Jersey and their department ID is 10, or if their salary is greater than 10,000. So let's say you have someone whose state is New Jersey and their department ID is 10, then they get selected. Let's say you have someone whose salary is greater than 1,000, but they're from Arkansas. They also get selected because this is an or clause. So this and this are separate. These two groups of parentheses are separate. So if they fit any one of this or that condition, then it returns them. But if they fit neither, then it doesn't return them. And even more about select. There's the like clause. So the like condition allows like sort of a wild card to be used in the where clause of the select, insert, update, or delete statement, and allows you to perform something called pattern matching. So it's easier to explain from here. So the wildcard percent allows you to match any string of any length. So select star from employee where employee name like meh percentage. That might look like gibberish, but what it does is it selects everyone from the employee where their employee name has MEH at the beginning and then anything at the end. So it can be Mehar, it can be Mehar 2, it can be Mehar 3, it can be just Meh, it can be like Mehal or Mehaj or something like that. Like it can be anything, like any string after that, but it has to start with MEH. Then there's employee name where emp name like %A%. That basically means anything at the beginning and anything afterwards, it just has to have an A in it. So anyone whose name has an A in it gets returned. And the last one is employee where emp name like MEH underscore R, which basically means a single character. Um, it it basically means where the employee name has MEH, then any character, and then R. So it can MEH AR, MEH BR, MEH CR, MEH DR, like anything like that. But it just selects one character. It's not like the percent. And then there's even more for select. So like I told you, there's a lot of stuff you can do with select, and it's one of the things you're going to be doing the most. So it's one of the things you have to learn the most. So there's the between clause. So the between clause basically lets you retrieve values within a range in a select, insert, update, or delete statement. Actually, no, the between clause actually lets you do anything from it lets you do anything in DML. Like you can do select, insert, update, delete, along with a lot of the stuff that we've been talking about before, like the like clause and the and or clause, like stuff like that is all available for any DML command, whether it's selecting, insert, updating, or deleting. But I'm just showing the examples for select. So like these can be universally applied to any of the DML ones. So what between does is it selects, let's say this command, select star from employee where it's salary between 1,000 and 5,000. And like this is kind of like an English statement. Like you would say this, like select everything from employee where salary between 1,000 and 5,000. And that's basically this SQL command works, but it's the same thing as saying select star from employee where salary greater than 1,000 and salary is less than 5,000. You can just put between and it works. And between can also be combined with a not operator. So you can say select star from employee where salary is not between 1,000 and 5,000. So it's either less than 1,000 or greater than 5,000. So like 800 and 6,000 would both be returned, but 3,000 wouldn't. And so let's say you want to find the average salary of all employees in a school. The way you do that is with what's called an aggregate function, or just a function in general. So you can do select average salary from employee. So select average of the column from the table, which is employee. How to find the average salary of the employee based on their department. Select average of the salary column from the employee where their department ID is 1, their department ID is 2, so on and so forth. Or another way you can do this is by simplifying this is by just having one statement. Instead of one statement for each department, you can have just one statement in general using the group by and having clause. The group by clause divides the rows in a table into smaller groups, and then you can use that to filter them before you group them. So you can do select department ID and average salary from employee, then group them by department ID. So this selects the department ID column and the average of the salary column from employee, and then in return, what it returns is grouped by department ID. So you can group, so it returns all of the averages of all of the different departments grouped in the output, which is a lot better of an option. But this second one wouldn't work because you have an extra column. You have employee name in them, and it's not grouped by employee name. It's only grouped by department ID. And then you can also have the having clause. So select department ID average salary from employee, and you group by the department ID that has an average salary of over 5,000. So you get the department ID, you get the average salary from everything. It's just like this row, just like this command, but you only show the departments that have an average salary of over 5,000. So it's really powerful stuff you can do with the having group by commands. The more like you get familiar with this syntax, the more you can do with selectors. The more you can do with the DML commands. You can do some really powerful like changes and additions and rules from a database with just like one or two lines. Now we're on to DCL. Yeah, now we're on to DCL. So DCL is data control language, which is a syntax similar to computer programming language used to control data stored in a database. So it's basically authorizing users to do specific things. So grant lets specific users perform specific tasks. So you can say, okay, I grant you permission to only select. You can't change anything in the database. You can only select and get outputs out. You can only read from the database. You can't write to it. Or you can say, I give you permission to do everything. I give you permission to select and insert, but you can't delete anything. Only I can delete it. Only I, the owner of the table, can delete it. So you have a lot of customization, a lot of options available for what you want to do. So let's say you want to grant privileges on a database object to user. This is the general syntax of it. Grant whatever privileges you want to grant on whatever the database object is, if it's a table, view, index, etc., to the specific user. So let's say I want to grant select, insert, update, and delete on the employee table to myself. Or I can just grant all on employee to myself. Now there's also revoke. You can just so you can grant permissions, you can also take people's permissions away. So you can revoke any combination of select, insert, delete, alter, all, and the syntax is the same. You revoke privileges on the database object from the user. So let's say you gave me all the permissions, you can revoke all the permissions on the employee table from me. Instead of like before, you grant permissions to me, here you revoke permissions from me. So you have to make sure you use a specific word. It's not from for both of them. You grant to and you revoke from. And the last thing is TCL, commit and rollback. So basically, a lot of this has to do with what's called transactions. So the purpose of it's called like transaction control language, and it's a TCL. So the purpose of transaction processing, or what it is it enables users to see a consistent view of the database so that every single one of the users sees the same version of the database as everyone else. So it prevents users from viewing or updating data on the database when there's still like uncommitted transactions going on. So let's say I make an update to a database, but it hasn't gone through yet, and then someone else tries making an update to that same row. It prevents that sort of conflict from happening. So if I make a change to the database, it's not committed yet, then no one else can change it, and no one else and everyone else sees the version of the database that still doesn't have the commit in it yet, or that has that commit in it, so they know not to make that change when it's still being pushed through. And a transaction ends once a commit happens or a rollback happens. So like when you're in an SQL session, like the things you keep doing will always like keep changing the database until you hit commit or until you like type commit. Then it'll commit that to the database, and then everyone's view will be updated with that newer version of the database so that they know what the latest updated version is. Or if you do like a database, a DDL command or a DCL command, then that automatically causes a commit to happen. Or if you quit the session, that also causes an automatic commit. And the system crashing will also cause, no, actually, no. A DCL statement will execute, that's causing an automatic commit. But if you exit the session or the system crashes, then the transaction ends there. And rollback, what the rollback lets you do is it lets you undo changes made by transactions. So if you commit and you realize you made it, and you keep changing the database, you realize you messed something up, you can roll back to a previous commit and make it like the mistake never happened. And with the commit and rollback statements, using the combination of them, you can ensure that everyone sees the same version of the database, which is data consistency. You can preview changes that you make before you make them permanently, so you know that whatever you're making for sure. And even if you do make a mistake, you can be sure that you can change it or reverse it. Um, so what we're going to talk about now is what's called SQL set operators, which is like if you have experience with like sets and stuff before, then you might know some of this. But this is sort of universal, not just SQL, but to like a lot of programming and a lot of stuff in general, which is the idea of union, union all, intersect, and minus. So the easiest way to explain these is using Venn diagrams. So union are rows from both queries after eliminating the duplicates. So the top right is union. Let's say you have two circles, like you have a Venn diagram. So what a union returns is all the rows from both the queries, so both circles, everything from them, but not the ones they have in common. This center section is not included. Union all makes sure this center section is included. So it has everything from the left, everything from the right, and everything that's common. This one eliminates the ones that are common. Next, if intersect. Intersect basically means that you have these two database objects, these two tables, whatever the database objects are, and if you want to find the intersection, it's just what's in common. Union is everything that's not in common. Intersect is what's just in common. What's the intersection of those two things? And minus is rows that are in the first query. Rows that are in the first query that are not present in the second. So it's just one or the other. Important things to know is that all set operators have equal precedence. Like no one of them is greater in priority than the others. And if a SQL statement has multiple set operators, then it evaluates them from left to right, so from top to bottom, if no parentheses are specified. So if you have a union and intersect and a minus, if you want to combine them, then it goes from left to right. So to keep that in mind, you should use parentheses to control the order of the evaluation. So the union operator, like I said before, returns all rows that are selected by either query. So it returns everything, but it eliminates any duplicate rows. Union all does not eliminate any duplicate rows. And the guidelines for using these commands is that the number of columns being selected from both must be the same, the data types must be the same, and null values are not ignored during duplicate checking. So null values, if two columns have null values, they are considered duplicates. And by default, the output is sorted in the ascending order of the columns. They're sorted in ascending order rather than descending order. And with union, they're sorted in ascending order, but in union all, since you're returning everything, the output is not sorted. Let's say you have this top table at the right, the Facebook table, has name and location for Anmol, Canada, Arch, New York, Druve, California. And the LinkedIn table has Arch, New York, Druve, California, Mayher, New Jersey. So as you can see, you're able to do the union all command because they both have the same data types and the same columns. So when you call union all returns everything, including duplicates. So it has Anmol, Canada, Arch, New York twice because it exists in both of them, Druve, California, and Mayher, New Jersey. But in union just has Anmol, Canada, Arch, New York, Druve, California, Mayher, New Jersey because it has everything, but it eliminates the duplicates with Arch, New York, and Druve, California. So it just is 4 compared to the 6 in this one. As you can see, yeah. Oh, and these are the sort of commands that you would do. So select name location from Facebook, union all. Select name location from LinkedIn. So this first select gets the first query, then you do union all, and then the second query. This one select Facebook, first query, union, second query. So the union, intersect, those commands will all run on one query, then the set operator, then the second query. The next set operator is intersect. So the intersect operator returns all rows that are common to multiple queries. You do the first query from table A, intersect whatever the second query is from table B. Reversing the order of the tables does not alter the results because no matter what, they have the same things in common. And intersect does not ignore null values. So yeah, as you can see in the bottom left Venn diagram, it's what's in common. The next set operator is minus. So use the minus operator to return all distinct rows selected by the first query but not present in the second query. But unlike intersect, order does matter. Because let's say, one second. Let's say here you do select from table A first and then select from table B and then you do the minus. Then it selects all distinct rows selected by the first but not present in the second. If you do B first, then it selects everything from B that are not in A. So these are two separate things. The order does matter when you're doing minus. And some more facts about set operators are the order by clause can appear only once at the end of the compound query component because queries cannot have the individual order by clauses. You can't order in descending, ascending individually. The order by clause recognizes only the columns of the first select query. And yeah. Now there's what's called joins. So in SQL, joins are used to query data from two or more tables based on a relationship between certain columns in those tables. So if you want to query from multiple tables at once, that's where you would use the join command. So there's different types of join. There's inner join and outer join. And inner joins have different components within them called a full join. And outer joins have left joins and right joins. So the first thing we'll start off with is an inner join. So let's say you have this command. Select employee ID and name and the company and the city name from the table of employees, and you inner join employee city on employees at employee ID equals employee underscore city dot empty. So this might seem kind of complicated, but what it does is, let me see if I can show this a better way. So here you have the first column with an emp ID of 1, 2, 3, 4, and then you have Mehar, Arsh, Anmol, Dhruv. Then you have the next column, this next thing called employee city. So this column just has the employee ID and their name. This one has what's called empty, which corresponds to the employee ID in the other one, and then it has their city name. So you can only use an inner join when since these two are related, these two columns have some sort of like correspondence to each other. That's why you can use a join. And when you're joining it on the employee city, what it does is it does emp ID 1, 2, 3, Mehar, Princeton, Arsh, Dayton, and Mole, Kendall. So as you can see, since you're joining it on employee IDs equals employee.city.empty. So you're saying that this column is equal to this column. So you could set these two columns equal to each other and set them as one emp ID column. And since these two columns are equal to each other, you know that Mehar is ID of 1, and ID of 1 corresponds to Princeton. So when you join them, it gets Mehar, Princeton. Same with Arsh, Dayton, and Mole, Kendall. But Dhruv does not show up because Dhruv does not have an entry in the employee city table. So he does not show up in the final output. Then you have join, outer join. An outer join is a join operation that includes rows that have a match plus rows that do not have a match. This one, the inner join, did not include ones that didn't have a match. Like it did not include Dhruv. But outer joins do include ones that do not have a match. And the difference with the inner join because rows return even when there are no matches through the join criteria. So what are the different types of joins? The different types of outer joins are, one is the left join. The left join keyword joins two tables and fetches a return based on a condition, which are matching in both of the tables. The unmatched rows will also be available from the table before the join clause. So the unmatched rows from the table before the join clause are available, but the ones after are not. So in this example, table name 1, the unmatched rows from table 1 will show up in the output, but the unmatched ones from table 2 will not. So it'll take everything from table one, and it'll wherever on this condition, well, table one column name equals table two column name, but it will include the matching ones from the left one. So there's left join. So if you look at it like a Venn diagram with the first table being table one and the next one being table two, you can see what's called a left join because it joins from the left. Then right join is a similar thing, except you're joining it from the right. The unmatched rows will also be available from the table after the join clause. Instead of the unmatched rows being from the one before it, it comes from the one after it. And then you have a full join. A full join returns all rows from the left table and right table when there's a match in one of the tables. So it combines the result of both the left and the right join. So instead of having just like here the Venn diagram, which is a pretty good example, instead of having just the yellow all on the right or the yellow all on the left, what a full join does is it basically just returns both tables on their match. So it has both table one and table two on the condition that they match on. And then you have another thing you have within SQL, another type of database object rather than a table is what's called a view. A view is a logical or virtual table based on a query. And they're created through the use of a create view command, which is a DDL command. And then it incorporates use a select statement. And views are queried just like tables. So you can create a view just like you create a table. You can query a view just like you query a table, except it's a specific subset of that table. So views let you restrict data access. So let's say you have an SSN column, but you don't want people to access that SSN column publicly. You can make a view of the table that includes all of the columns except for the SSN table. You can present different views of the same data. You can provide data independence and make complex queries really easily by reducing the amount of columns that are available. So let's say you have, all right, so let's say a sample use case of this. Let's say you want to create a view called emp underscore view or employee view with the columns of employee underscore ID, employee underscore name, salary, and hire date as select emp ID, ename, sal, h date from employee. And they might be wondering, well, you're just selecting the same things. What's the point of making the view then? As you see on the right, when you describe the employee column, the column titles are emp ID, ename, sal, and h date. For someone who's familiar with a database, that might be easy for them to read. But for someone, if you're presenting like higher ups or presenting it somewhere else, they might not know what emp ID or ename or sal or h date is. But what you can do is you can take that same data and make a view of it with more descriptive column names like employee underscore ID or employee underscore name or salary and hire date, and make it so that the table is much more easy to view and it's much more easy to query because you know exactly what the columns are, and you can present a view of that data set of the data that's a lot more user friendly. The next subtype of database object you can make is called an index. An index is a database structure that provides a quick lookup of data in a column or columns of a table. Okay, just make sure. All right. Yeah, so an index is a database structure that provides a quick lookup of data in a column or columns of a table. Indexes provide a faster access to data for operations that return a small portions of a table's rows, and clauses like from or where favor an index, but insert update discourage an index. So let's say you have the same table from before, where you can describe by the way is a command that lets you describe a table to see like what columns it has and what types those columns are. So if you describe employee, it has emp ID number, ename, varchar, salary of a number, and the h date of date. You can create an index called emp underscore index underscore one with the names of employee ID, employee name, salary, and hire date on the employee AE name column. You can also create another index for the employee ID in their salary column. So you can create indexes for specific columns to allow for ease of use when you're querying them. And it's kind of like if you know binary trees, which is kind of a more complicated topic in computer science. But let's say this center column is a salary of $500. Then if you create an index on the salary, then anyone whose salary is less than $500 will go here. And then the further left you are, the smaller the salary will go. So let's say this is $500. This could be $400. And then this could be 200, and this could be 300. And this is 500. This could be 600. This could be 700. This could be, I don't know, 550, 549, and this could be like 699. So the way that this makes the where clauses faster is instead of the computer having to go through every single one of the rows to find where the salary is greater than 500, it can just say, oh, salary greater than 500. I can just ignore this half of the data and only look at here and return everything that's here. So it makes the from or the where clauses a lot faster. But it makes insert and update clauses a lot slower because it has to navigate this complicated tree just to add a data in an area where it should be. Okay, and finally, what I just want to share is there's a website called livesql.oracle.com that lets you make an Oracle account, and you can search up scripts, you can search up tutorials, and you can just start playing around with SQL in the laboratory environment. You can just do whatever you want with SQL, and it lets you play around with it. It's a really great tool for learning SQL, looking at tutorials, looking at community-made scripts, and a lot of really great things for learning how to use SQL. And that just about concludes our presentation for today. If you guys have any questions about SQL specifically, you can email sql@agisnavigator.org, and we'll be sure to send out the slideshow and this recording as soon as we can. This slideshow and this recording as soon as we can, along with the one from earlier this morning and from yesterday too, as soon as Big Market gets them sent out. So that concludes our presentation for today, and thank you guys for coming, and I'll see you guys next weekend.